Okay, let's do one more question on the LM Lagrange multiplier test. So let's look at this question from exercise 7, question 9. Okay, so the person first run the restricted regression, marks explained by study hours only, and then running the unrestricted regression. Marks explained by study hours and party hours, actually. And then she extracted the residuals from the restricted regression before running the auxiliary regression, which includes all the explanatory variables from the unrestricted regression. Remember, I must always give you the auxiliary regression. So if we compare the two regressions, I can argue that we impose one restriction on the slope parameter of the restricted regression because the restriction is B3 equals 0, so that the party hour variable would not feature in the restricted regression. Then I think we can actually do the LM test. Step 1, you should be fine with the null hypothesis and alternative hypothesis. And then step 2, n times r squared, sample size is 20. R squared, remember you must use the right r squared. It must come from the auxiliary regression, not from the two original regressions. Okay, 1.212, and then chi-square, alpha, I think alpha is it 5% or 1%? Okay, and then degrees of freedom is the number of restriction, which is 1. Okay, alpha is 5%. And then when you use the chi-square table, I'm not going to show you the table because you have enough experience now. This is the last chapter. You must have enough experience using the chi-square table. You should find the chi-square statistic of 6.635. Since n times r squared, 1.212 is smaller than chi-square stat, 6.635, the null hypothesis is not rejected. Okay, meaning the null hypothesis is more likely to happen, meaning the restricted regression is specified correctly. Maybe it is because maybe it is really better to leave out the party hours variables due to the possible strong collinearity between study hours and party hours. Although the other side of the argument is that if you leave out party hour, who knows if you commit underfitting in the restricted regression. So there are always two sides of a story. Okay. If we exclude an explanatory variable, maybe we can get rid of the imperfect collinearity, but at the same time, we are scared that we commit underfitting. So remember chapter 10, remember the remedies for imperfect collinearity or imperfect multicollinearity. We have two sides of the story. Either we do nothing if we are scared of committing underfitting, or alternatively, we decide to drop an explanatory variable if we are not scared of committing underfitting. Okay? Okay, then we can go back to the slides. Okay. Nested model is easy. It means I want to compare two regressions and want to know which one is better. This is called nested model. It means model A, you have x2 and x3. Model B, you have x2, x3, x4, and x5. And if all the explanatory variables from the first model, they all feature in the second model, which is x2 and x3, then we call this nested model. And then in order to compare which regression is better, I think the solution is simple. We can just do that F-test on marginal contribution of additional explanatory variables. And I'm not going to do it anymore because we have done it many times in chapter 8, actually. And then I actually have an example here. Exercise 7, question 11, you can see the first regression, chicken consumption is a function of income and price of chicken. And then the second regression, the same two explanatory variables still feature in the second regression, but then I add two more additional explanatory variables, price of the pork and price of the beef. Then this is an example of nested model. And then we can actually do the F-test on the marginal contribution of additional explanatory variables. And then if you look at the answers, this is quite a nice question 11. The answers are very detailed, so you can go through the answers. And then from the F-test on the marginal contribution, the conclusion is that we should add the two additional explanatory variables because they do contribute to the goodness of fit, to improve the goodness of fit of the regression. Okay? And then another way to compare the two regressions is back to basics. You can work out the adjusted R square of the two regressions, if you still remember adjusted R square. Okay. It works when sample size and k might not be the same. Clearly, k is not the same in the two regressions, providing the y in the same form, both in linear form in this case, then we can move on to calculate adjusted R-square. And then adjusted R-square is indeed higher in the second regression. Then it once again confirms that the second regression is indeed better. That is, the two additional explanatory variables do contribute and should be included. Okay, so the conclusion is that when it comes to the nested model, it is quite easy to compare the two regressions. We can use adjusted R-square and the F-test or marginal contribution of additional explanatory variables. But then now the trick is non-nested model. Then it becomes a bit tricky to compare the two regressions. So I give you a few examples of non-nested model. Let's look at the first example. Model C, you have x2 and x3 to explain variation in y, but then in model D, you have a completely different explanatory variable, Z2 and Z3, to explain variation in y. Then we say this is an example of non-nested model. The next one, model D and model E. Let's look at the first one. You have Z2 and Z3 as explanatory variables. And then in model E, although you still include Z2 and Z3 because you use different you now take log of Z2, log of Z3, which are not the same as Z2 and Z3. This is why this is also an example of non-nested model. And then the last one, F and G, although M feature as an explanatory variable in both models, the problem is that N only features in the first model, but not in the second model. And similarly, explanatory variable P only features in the second model, but not in the first model. And this is also an example of non-nested model. Okay. And then the suggestion is actually these are the three criteria to compare the non-nested model. Adjusted R-square, AIC and SIC I'm going to explain now. Okay, so this is the formula. AIC, okay, we actually want the lower the AIC, the better the regression. Because of this term, residual sum of square. Remember, we want the actual y to be as close as possible to the y hat. In other words, we want residual sum of square to be as small as possible. So the lower the RSS is, the lower the AIC. By the way, you don't need to worry about the formula for AIC and ask, am I going to calculate AIC? The answer is no. Remember, in the eViews output, you are given the AIC statistic. Similarly, the other stat is called SIC. This is the formula. Again, residual sum of square features. And again, using the same argument, we want actual y to be as close as possible to y hat. Therefore, we prefer a lower RSS. And the lower the RSS is, the lower the SIC is. So keep in mind, we prefer a regression model with lower AIC, lower SIC, but higher adjusted R-square. And do you see the R-square? I put a question mark. Remember the weird characteristics of R-square? This is why I don't recommend using R-square to compare two regressions. Okay, I don't think I need the slides anymore. Then we can just do the last question. Then we actually conclude the whole ECO311. So let's look at this example of non-nested model. The first regression, marks explained by study hours, party hours. Second regression, marks explained by lecture attendance, and then frequency to consult the lecturer. Then do you notice the explanatory variables are completely different in the two regressions? So this is an example of non-nested model. So use the following criteria. If we use theoretical thinking, I think I put a happy face in both. It actually means both regression makes sense because these explanatory variables, all of them are relevant. This is why I think I will give 1 mark to both actually. R-square, it is a questionable indicator. Remember, the k is already different in the two regressions, so I wouldn't recommend using R-square to compare the two regressions. Adjusted R-square, I think it is higher in the second regression. Do you see 0.9425? So I will put a happy face there. AIC is lower in the second regression, so I put a happy face there. And then finally, SIC is lower for the first regression. Let me delete this unnecessary row. So if I add up the score, okay, I get 2 happy faces for the first regression, but 3 happy faces for the second regression. So it's hard to decide here. So I think if I would be given a chance, I would rather suggest the following. I would rather rerun the regression as follows. Marks explained by all 4 explanatory variables. Don't you think this is the best solution? Okay. Then just let's look at one more. I'm not going to go through the third one, self-explanatory, but I would rather look at the second non-nested model. Okay. First one, marks explained by study hours, party hours. Then the second one, same regression, but I decide to run a double log model. Okay. I'm going to delete this row, R squared. We can't compare the R squared. Okay. If y are no longer in the same form, one is in linear form, the other is in log form. According to theory, I think both would make sense because study hours and party hours are relevant explanatory variable. But adjusted R squared is higher in the second regression, and AIC and SIC are lower in the second regression. Then if you look at the results, I think regression 2 is clearly much better. So the hidden message is we should rather run the regression as a double log model. Okay, so I just want to conclude this module. Remember, you have to read the prescribed chapter. If you don't make an effort to read the prescribed chapter at least once, then you can't think you are going to pass just by relying on the slides, study guides, and so forth. Then PowerPoint slides, you have to go through the PowerPoint slides first, and then the study guide or the lecture speech notes. And then finally, watch these online summary videos. Remember, I only provide a summary in my videos. I can't explain everything because I already provide you the lectures in silence with the study guide. Okay, and then practice. This is the module that involves calculations, in-class exercises. And again, try not to read the answers. Okay, in other words, please first make an effort to work out the solutions on your own instead of immediately referring to the answers. Okay, and then the last thing, you have to make your own study note. Remember, an example is exercise 8, that nice table when I try to summarize the chapters 10, 11, and 12 on definition, detection, consequences, and remedy. And remember, we also have a nice summary table exercise in chapter 10 when you have to explain imperfect collinearity, imperfect multicollinearity, perfect collinearity, and perfect multicollinearity. Okay. I really am strongly confident that if you make a serious effort and get all the text here, you should pass with flying colors. Okay. Okay, so that's the end of ECO311 summary video. So all the best, and feel free to drop me an email and consult me during my consultation hours. So good luck to your test and exams. Goodbye.